So in this video, we're going to explore a full problem of concentrations. And this problem, we can tackle it very simply if we're very organized. I always suggest that we're organized, and it's going to be very simple. We're given 25 grams of sodium chloride are dissolved in 600 grams of water. Calculate mass percent, volume percent, mass volume percent, molarity, and molality. So instead of tackling each of these directly, let's build a table to have all our information available, which is going to make this really simple. Okay, so in this case, what we're going to do is let's set up a very simple table where we're going to have we're going to write in a different color, so this is simpler. We're going to write solute, and then we're going to write solvent, and then we're going to write solution. And on the top columns, what we're going to write is mass, volume, and last but not least, moles. Let's just know that we don't need the moles of solvent and we don't need the moles of solution. So we're going to be able to fill this out as best as possible. Who is a solute? 25 grams of salt. Who is a solvent? 600 grams of water. So we're already being given that, and let's just put it directly into the table. 600 grams of water is a solvent, so I'm going to write it right here, 600 grams of solvent. And then we're being given 25 grams of sodium chloride, 25 grams. And we're not given anything else other than the density, and we still have a few boxes to fill out. So we still have a little bit of spaces that we need to fill out. We still need these 1, 2, 3, 4, 5. So let's just start filling out the simple ones. For example, if I know that solute and solvent equals solution, I can just go ahead and add this together, and this is going to give me 625 grams of solution, which is the mass of the solution. But now, how am I going to get the volumes? The volumes that we're going to get are very simple because we're being given density. So we know that we have 25 grams of salt, and we know that for every 2.16 grams, there's 1 milliliter of solution. So what I'm going to go ahead and do is I'm going to take 25, and I'm going to divide it by the density, which is 2.16, and that's going to give me the volume of solute, which is 11.57 milliliters of salt. So we converted this using the density of the solute, which is sodium chloride. The density of the solvent, which is water, is 1 gram for every milliliter. So that's pretty straightforward. If we have 600 grams and there's 1 gram per milliliter, we know that the volume of the solvent is 600 milliliters as well. Once we get the identity of the solute and the solvent, I mean their volume, we can just go ahead and add this, and we know that the volume of our solution is 611.57 milliliters. The last step to calculate is actually moles. Moles of what? Moles of solute. So we know that there's 25 grams, but we haven't calculated the molar mass of sodium chloride. But we know that if we add 22.99, which is sodium, plus 35.45, which is chlorine, the molar mass is 58.44. So if we do a quick conversion factor, 25 grams over 1 divided by 58.44 grams for every mole, grams cancels out, and we know that 25 divided by 58.44 is going to be equal to 0.43, which is our rounded up value. And our moles of solute are 0.43 moles. We took, let's see, I don't know, maybe like 3 minutes to do this with the explanation going on. But other than that, once we do this, it's quite simple. The only thing we really need to do now is substitute into our formulas in order to get our answers. And it's just, we really need to take care of what we're doing. And how do we do that? We just look for our formulas. We have to know them by heart probably, which is quite important. But since I don't want to write them all over again, I already have them here. And we know that mm is grams of solute, grams of solution times 100 VV is milliliters of solution times 100. And grams of solute, milliliters of solution times 100 is MV. Let's complete this really quickly, and let's know that molarity is equal to moles of solute divided by liters of solution. And we don't multiply that times 100. And last but not least, let's use another color marker. Let's see, I have some blue here in another shade. Molality is equal to moles of solute divided by kilograms of solvent. Remember, this is quite different, okay? So now the only thing we need to do is we need to actually substitute these values that we created, and it's really just plug and chug and trying to get all these values calculated in here. So grams of solute, grams of solution, grams of solute, grams of solution, 25 divided by 625 times 100 is equal to, and we put that in the calculator, divided by 625 times 100 is 4% mm. First problem done. Second problem, it's asking us for VV. VV is milliliters of solute divided by milliliters of solution, which we already have right here. 11.57 divided by 611.57 times 100 is equal to 11.57 divided by 611.57 times 100 is 189% VV. Okay? Good. Again, grams of solute, 25, divided by milliliters of solution, 611.57 times 100 is going to be equal to 25 divided by 611.57 times 100 is 4.09% MV. And last but not least, moles of solute, we know it's 0.43, which is going to be helpful for both our molarity and molality. Liters of solution, we don't have it, but remember, we can just move the decimal 1, 2, 3 spots, and we round up 0.61 liters, 0.61 liters. And then for this one is kilograms of solvent. So kilograms of solvent is 600. We don't have it. 1, 2, 3, 0.6 kilos. 0.6 kilos. And we're going to get our final answer, which is 0.43 divided by 0.61. 0.7 big M. And for this answer, 0.43 divided by 0.6. 0.43 divided by 0.6, we're going to get 0.72 lowercase m. And as you saw, we solved a full problem with all the information, creating a table where we calculated the missing information using density and molar mass, and then we just plugged it into our formulas. Remember, everything is divided by solution except for molality, which is divided by kilos of solvent, which you can also get from the table, moving your decimal point to the left 3 times. That's it.